So, hello everyone, and welcome. Good afternoon. Um, this is the Data Lab Workshop, Introduction to Data Sourcing or Data Sorcery. The actual presentation part of this workshop shouldn't take more than an hour, despite the 2-hour time slot that I've reserved. So that leaves us with plenty of time for answering questions or demoing even certain data sources. This Data Lab workshop is run by Data Services, which is a department of the WashU Libraries that serves undergraduate students and graduate students, faculty, and staff. We have 6 core services, one of which is data sourcing. What that means for WashU folks is that if you have questions about how to find quality data sources, we can help you. These can be free, publicly available sources of data or paid data sets that we have access to through the library. We can also help you evaluate and understand a data source. This is the data services team. We have Jennifer Moore, our fearless leader, Sarah Swans, our digital humanities expert, Harper Tooch, our 3D data, AR, and VR expert, and then Molly Webb, Ryan Wallace, and myself, all of whom specialize in geographic information systems and data to some degree or another. You can get in contact with any of us by going to our website. Just web search for Data Services WashU, and you'll find us. All right, so that's the team. Let's move on to the data. Let's say that you have a research idea and you're looking for data to use. Where should you start first? So consider who might have collected the data you're interested in and explore their website. A great first source are relevant government agencies at all levels, federal, state, and local. This can include the USGS, the United States Geological Survey, the St. Louis Federal Reserve, the Missouri Department of Education, or the City of St. Louis Department of Health. You can find some nonprofit, non-governmental, or intergovernmental organizations. Some examples of this can be the East-West Gateway here in the St. Louis region for environmental data, or Think Health St. Louis, which tracks the uninsured population by zip code. You can look at private businesses or industry groups, and of course, other academic researchers. In this same vein, you can look for data sets cited in publications. So if an author of a publication has created their own data set, do feel free to reach out to that author and ask for a copy of the data set. They'll often have an email listed that you can reach them by. You can also, if they used another source of data, follow their citations to that source of data. Some other publications that often cite data sets include government reports, and that's at the federal, state, and local levels, and so-called gray literature. And this gray literature includes reports and working papers or white papers produced outside traditional publishing channels by NGOs and businesses. So those are available, but do evaluate those carefully. If an academic researcher has misplaced their data set, you can hope that they submitted a copy to a repository. These repositories collect, manage, and preserve data sets for the long term. You can also use aggregators, which harvest information from multiple databases, repositories, or institutions to make data sets easier to find. Examples of these aggregators could include Google Dataset Search and data.gov. Back to repositories, they can be divided into 2 groups, general and disciplinary. The advantage to using a general repository is that they are somewhat easier to deposit into and therefore have much more data. On the other hand, they often reject and do not store data that has personally identifiable markers. So you may have to go hunting in a disciplinary repository for that. With their narrower focus, it may be easier to find the data you're looking for in that disciplinary repository. Figshare, Dryad, and our very own WashU research data repository are some places to start looking in the general repository sphere. If you want to look through the disciplinary repositories, but don't know where to start, you can check out the site Re3Data. And this site will allow you to search through its registry of disciplinary repositories. And I can show what that might look like. So here I am on the homepage of re3data.org. I could type in a keyword like industry. And that's really generic, but we're going to see what shows up. And let's find a good example here. One repository that comes up here is Open Data Areas Alberta. We can see the name. We can see the types of the subject of the contents included in this repository, and even the type. So we see that's tabular scientific and statistical data with some images, and we can see the country of origin. This one is in Canada. This one is from India. If we click on a link, it shows some more information. Click on this institutions tab, gives us a better idea of like where it's located and the type. Here on terms, this can give you an idea of the types of access of this repository. So this one is open. It's not restricted in its access. Let's see, some might be more restricted. Oh, this one is also open all the way. But you can check through these tabs to make sure that you can access it. If you're feeling overwhelmed with these options and you don't know where to start, speaking with a WashU subject librarian could help you narrow down some potential avenues. I've included names and links to some of the relevant subject librarians here on this slide. This whole deck will be mailed out to everyone who registered here, so you will get all these links. One last thing when searching for data sets, always check the license on the data set. I've included a lot of different types of sources in the last slides, and they may have different restrictions on reuse, particularly the non-governmental, non-academic sources. Those of you in the medical community are also very aware of HIPAA and the privacy restraints regarding personally identifiable data. But that is something that could conceivably come up in any field with human subjects. So in short, be aware of how the data you are looking for, how it can be shared. I'm going to give you like 3 minutes to just think about the things I've said, absorb it before I hit you with some more information on evaluating data sources. All right, it's been about 3 minutes, so welcome back, everyone. And we are going to talk next about documentation. So I'm sure any of you that have done even a bit of research have run into the problem of data sets without proper documentation. It's frustrating. When others produce good documentation, it helps you to understand someone else's data and decide if and how it might be useful for your research project. Data sets without documentation are difficult to understand and difficult to share. There are 3 general types of documentation that you might run into: the README, the data dictionary, and the codebook. The README is a text file that contains metadata about the data set. data about the data, if you will. So this following list, I'm not going to read it all out. It includes the type of metadata we require in the WashU data repository for a data set submission. So if you've submitted a data set, you'll also submit this README, and you need to include this minimum amount of information. So anyone who's looking at this data can at least learn this much about it. You'll notice that one of the items is an inventory of file names and a brief description of those files. The next type of documentation, the data dictionary, expands on this. If your data set includes any type of tabular data, a data dictionary is required. This includes a list of fields in the table and what each field means. This is a description that often includes the units of measure, precision, and range of values involved. The final type of documentation is called a codebook. This is like a data dictionary for qualitative data, like coded survey responses and classifications, but it should also include the layout and structure of the data file. I've included a link here to REDCap, which is a web-based application that can help you design a code book. So once you've found data and you have access to its documentation, you should be able to make an evaluation on a data set and decide if it is usable for your research. These are the types of questions you should be asking of the data when evaluating how the data was collected. So what were the methods or instruments used for data collection? Is the data representative of the population? Or what is the sample size and how were the participants recruited? Was this data ethically collected? As an example here, let's say you plan to use data from Twitter or X to understand what people think about a political candidate. Understand that data set would then not be representative of an entire population because active X users represent only a small fraction of all voting age Americans. So in this instance, you could only infer what X users think of the candidate, but not what all Americans think of the candidate. I've included at the bottom a link with more questions you can and should ask about how your data was collected. You should also examine the variables themselves in a data set more closely. Look for gaps or holes in the data. Are there empty cells or missing years? There may be valid reasons for these gaps, or they may indicate a flawed data set. Sometimes we have to make do with a flawed data set and acknowledge the flaws. For example, if a data collection instrument such as a thermometer broke on a specific date, we may never be able to fill in that particular missing data. It is just lost. With other sources, we might be able to fill in missing pieces. We should also ask if a variable is using the right level of measurement. Ask if the data is using raw numbers or proportional values, or if there is a margin of error. And again, I've included a link to more questions to ask of the variables specifically. We should also try to understand what biases might be present in the data. Common biases you might encounter are selection bias, confirmation bias, or survivorship bias. In the previous Twitter example, we have a selection bias because our results are representative of just Twitter users and not the population at large. You can also encounter selection biases when deciding how survey or focus group participants are recruited and selected. Are they selected randomly? From what pool of population? Are the participants recruited by other participants? That's called a snowball sample. And in that case, they wouldn't maybe not reach a population that you want to study. Confirmation bias, on the other hand, is the tendency to actively search for, interpret, and retain information that matches your preconceived ideas and beliefs. So is data disregarded that doesn't conform to a hypothesis? data that does conform? Is it critically evaluated? The final type here is survivorship bias, and that occurs when a visibly successful subgroup is mistaken as an entire group because the failure subgroup isn't visible. So when you consider only the observations of a surviving group and ignore those that did not survive. This could happen when you are looking at patient survival rates or startup entrepreneurial success rates. And again, more links at the bottom. Let's take another quick break before we get into the meat of the workshop, which will be big lists of data sources. All right, it's been about 5 minutes, so welcome back, everyone. Here we are going to transition from general data source tips to examples and lists of specific sources. So a great place to start, especially, well, when you are looking at local and regional data, includes many of the sites from our local and state governments here. So the city of St. Louis and also the county of St. Louis operate open data portals that are easily searchable and have data in a variety of formats, from tables to geospatial shapefiles. The East-West Gateway is fantastic for environmental type data. And at the state level, the Missouri Spatial Data Information Service and Illinois Geospatial Data Clearinghouse operate or maintain large and continually updated clearinghouses of geospatial data. This type of data includes land parcels, road details, sidewalks, different types of planning uses and services, as well as administrative boundaries, also school locations and boundaries within the regional area. The US Census cannot be ignored when we talk about socioeconomic and demographic data within the United States. It is just quite simply one of the most comprehensive sources. It operates several different products, and two of the main ones are the decennial census. This is the big one that most people think about when they say the census. And this is a count of individuals taken every 10 years. On the other hand, the American Community Survey, or ACS, is a statistical sample of the population taken every year. So it's not counts, and there's some margin of errors involved in the ACS, but it's needed for those years in between the decades. Both of these products include counts, estimates, and projections of a population based on a large variety of variables. And I just have listed a few of them here. They include more basic ones like the age and sex of a geographic area, to whether the native versus foreign-born population, income levels, SNAP food stamp usage, disability, and educational attainment. The US Census aggregates data based on a number of geographies. So you can't look up people based on just their address and an exact point in the United States. Instead, it's aggregated into larger areas so that you can't personally identify someone. On this chart to the left, the census blocks are the smallest level of census geography. And if you go up the middle column especially, it can be aggregated up into these larger and larger groups. So census blocks can be added into block groups, which a group of block groups makes up a census tract. A group of census tracts go into a county, and so forth. There are trade-offs to this geography aggregation, and that is that the smaller groups, so census blocks and block groups, have smaller sample sizes, smaller number of people. So they may have larger margins of error. In the worst case, you may have margins of error that are larger than the number of people in the tract. So there may be, or in the census block. So you may have 500 people living in a census block, but a margin of error of 600, meaning you can't really trust the numbers coming out of that census block. On the other hand, I know a lot of us look for really local level data. So the trick is finding census blocks that have a acceptable margin of error. We also have to consider, especially with the ACS, whether the product is a 1 year versus a 5 year. So a 1 year ACS data set is aggregated over a single year. Like the geographic area, it's the smallest sample sizes are less reliable. However, these 1 year data sources are also the most current. These come out every single year. So use these when currency is the most important factor or when you're analyzing large populations. These 1 year products usually are not available for smaller geographies. On the other hand, 5 year data sets are averaged over a moving 5 year period. And so they have the largest sample size and are the most reliable. On the other hand, these often lag by a year or more, so they're not as current. But use these when precision is more important or when you're analyzing small populations. When using the US Census, do consider that the questions involved in the census and the geographies themselves change over time. New census tracts, block groups, more geographies are added with every census that are subdivided out of previous ones. So if you're looking at a longitudinal study over time, your areas may not line up correctly. It is also important to consider that there are hard to count populations, so that the census often historically undercounts certain groups like young children, folks of color, rural residents, and low-income households at higher rates than other population groups. These populations are often undercounted. So moving on to some other specific data sources, some publicly available health-related sources include the Centers for Medicare and Medicaid Services, the CDC, the county health rankings, the Missouri Public Health Information Management System, the Missouri Cancer Registry and Research Center, and the MISDIS and Illinois Geospatial Data Clearinghouses. With these particular data sets, it is important to note that they rarely get to the local level or lower. These are often county level reports. So if you're looking for smaller neighborhood level types of data, only the census and this Missouri Public Health Information Management System get to a sub-county level. And this is largely because of privacy concerns. In terms of economic data, CRED is the most user-friendly, and that is run out of the Federal Reserve of St. Louis. But the Bureau of Labor Statistics, the Economic Census, the Bureau of Economic Analysis are all other excellent government-run data sources. If you have a WashU ID, if you're a member of WashU, and you're looking for geospatial data sets related to business, I do recommend looking at the Esri Business Analyst for ArcGIS Pro add-on. And this integrates well with other census data and includes like business and owner characteristics, product inventories, gross margins, and profits. You can get some good information over time as well. In terms of environmental data, the USGS is an excellent source for hydrology and natural disasters, while the Homeland Infrastructure Foundation level data includes a lot of point level data throughout the United States, showing the exact locations of power plants, hazardous chemical facilities, and energy infrastructure, among others. There's also Climate Trace for greenhouse gas emission tracking. Because I do specialize in GIS, I do have to recommend two more geospatial data sources. And that includes our WashU GIS LibGuide. And that itself includes a huge number of links to more local, state, and national, and even international sources of geospatial data. And just a reminder that geospatial data can be environmental, it can be market, it can be health, any of these with a geospatial component as well. I'll also promote the Esri Living Atlas of the World, which is already integrated into Esri ArcPro, into the geospatial software. And using this service will often eliminate the need to go searching for like census data and boundaries from other sources. You can just download it straight from within the ArcPro environment, and it is kept continually updated and curated as well. All right. That is it for this brief overview of publicly available data sources and how to evaluate them. We have time for me to show some data sources, or I can answer questions.